Okay, the rules for naming ionic compounds containing multivalent metals. A multivalent metal is a metal that can have more than one positive charge. In the name for the compound, Roman numerals in brackets follow the metal to indicate the charge on the metal. If you have a formula, though, first you have to figure out what the charge on the metal ion is. We can use the reverse crisscross rule or the zero-sum rule to figure it out. And I'll show you both methods. So SN and O. So this is tin something oxide. So to determine the charge on tin, you can do the reverse crisscross, but it's a two-step because you have to double check the numbers. So if I reverse crisscross, the numbers come up. So this is saying that tin has a charge of 1 and oxygen has a charge of 1. But we know oxygen has a charge of -2. So we would have to multiply this 1 times 2. If we multiply that by 2, we have to change the tin also by 2. So this would be tin 2 oxide. What had happened when this was originally written, when you do cross and drop, you reduce the formula to the lowest common. So this would be SNO. Now, if we did the same solution, but with the same formula, but with zero-sum rule, here's our negative on the right, and here's the positive on the left. Oxygen has a charge of -2. The total positive has to equal the total negative. So the total positive here would have to be +2 to counter the -2 on oxygen. So if this is tin 2 oxide. Let's do another example. We'll do it with tin again. So, zero-sum rule. Zero-sum rule says oxygen is always -2. There is 2 of them, so we multiply that -2 times 2 atoms. So we have a total of -4. Tin, there's only 1 of them, so the total positive has to be +4, and there's only 1, so this compound is called tin 4 oxide. If we had done the reverse crisscross, 1 would have come up for this, 2 would have come up for this. You have to double check it. Is oxygen -2? No, it's 1. So you have to multiply by 2. So now the negative is 2 and the positive is 4. So it is tin 4 oxide. So it works using either method, but if you do reverse crisscross, you have to double check that the charge you get on your negative ion is the correct charge. And that's exactly what we've had to do with these last 2 examples. Now what I want you to do is just pause this video for a minute, and I want you to try to name these 4 compounds using whichever method you're most comfortable with. Okay, so CuCl. If I do zero sum, chlorine is -1. There's only one of them. Copper must be +1 because they both have to add up to 0. If I did the reverse crisscross, they would both be 1, 1 plus and 1 negative. Chlorine is 1 negative, so this number stands. So this is copper 1 chloride. Second one, CuCl2. Reverse crisscross. Zero sum rule. Chlorine is -1. There are 2 atoms, so we multiply that by 2. So the total negative is -2. So the total positive has to be +2, and there happens to be only one of them. So it is copper 2 chloride. If we were doing the reverse crisscross, the 2 would come up, the 1 would come up. Chlorine is -1, so this is correct. So it also indicates that it's copper 2 chloride. So again, you pick which method works for you. FeO. All right, reverse crisscross. There's subscripts of 1. Oxygen is not -1, so I have to multiply it by 2 to get -2, which means I have to multiply the iron by 2 as well. So it's iron 2 oxide. If I was doing zero sum, oxygen is -2. There's only one atom, so the total is -2. The total positive must be +2. There's only one iron, so again it indicates this is iron 2 oxide. Last one, Fe2O3. All right, so reverse crisscross. 2 goes there, 3 goes there. Oxygen is -2, which means this iron is iron 3. If we look at zero sum, oxygen is -2. You notice for zero sum we always start with the -1 first. There's 3 of them, so the total negative is -6. So the total positive has to be +6, but there's 2 irons, so 2 Fe's make +6. So what you do here is you divide your total positive with the number of atoms, so you get +3. So both of these indicate that this is iron 3 oxide.